Okay, let's try this question here. They say that the graph of this function here, or whatever it is, y equals x plus 12 over x, passes through a point 2 and b. Determine the equation, passes through a point A, 2 and b, so 2 and b fits in here. Determine the equation of the line perpendicular to the tangent at the curve of A. Well, if we want to find the equation of the line tangent, we have to take the derivative and use that gradient. And if we wanted a perpendicular, we'd take that gradient, turn it upside down, and make it negative. But first things first, let's figure out what b would be. Well, we just take this x value of 2 and we put it in there. And we go 12 divided by 2 is 6 plus 2, so 2 and 8 is that point of where the tangent is at A they're talking about. Well, now we got to find the derivative. What do? Put it in the right form so we can take the derivative, 12 times x to the minus 1. The derivative of x is 1, and minus 1 times, there's minus 12, x to the minus, there's the derivative. Now, if we want to find what the gradient is there, right at that point, the gradient of the tangent, we just have to take 2 and put it into the gradient formula right here. In fact, that's what we do. We put 2 in there. And 12 times 2 to the minus 2 means 12 over 2 squared. That's 12 divided by 4 is 3. 1 minus 3, that's minus 2. The gradient of the tangent's minus 2. A perpendicular line, we have to take 2 over 1, turn it upside down, make it a half, and change the sign. It's a half. The perpendicular gradient is a half. So there you go. There's the perpendicular gradient. Now, what are we going to do? Well, we want right at 2 and 8, we want to find the equation of the line with this gradient. Well, that's easy. Just put in m is a half, put in y1 and x1 of 8 and minus 2, and there's your answer. Half times minus 1, add 8, you get where it is, the equation of the line that's perpendicular to this tangent. Well, that's a lot of thinking, but that's how it works. You see the tangent has a gradient of minus 2, the perpendicular one a half. Just put it in the gradient point formula, the 2 and the 8. See, there it goes, the gradient. There you go. Now the next question says that g of x is a tangent at some point at x equals 1. I don't know what y is, but there's the equation of the tangent. There's the tangent line. I could figure out what the y value is if I took 1 and just put it in here. In fact, let's do that. G of 1 minus 8 times 1 plus, it's 12. So 1 in the 12 is the point of tangency. It's a point that fits on F, and it's a point where the tangent line touches. Well, this is a harder question. We know two things. We know at 1, the gradient is minus 8. And we know at 1, it gives a y value of 12. Well, if at 1, it's got a y value of 12. So if we let f of 1 be 12, and then put 1 in for x, we get a formula here. 1 cubed plus a times 1 squared plus b times 1. Hey, it's just a plus b here. 1 plus 18 is 19. Take it away. A plus b equals minus 7. There's one formula. But then we've got another formula. We could take the derivative of this thing, and let's just do it with the a's. Let's just take the derivative. 3 times x, bring it down 1. 2 times a is 2ax. 1 times b is b. 18, the derivative is 0. There's the derivative. But hey, when we know at the 1, the derivative is equal to minus 8, so we can build another equation. So, hey, you can see, look, Mr. Rob made a mistake. He was supposed to subtract 3 from both sides, and he added 3. But he fixed it up. He subtracted 3 now, minus 8, minus 11, and 2a plus b. Now we take these two equations, just put them over top of each other. Now, if we subtract b minus b, 2a minus a is a, and minus 11 minus 7, there's my answer. A's got to be minus 4. And if a is minus 4, b's must be minus 3 to make this true. Minus 4 plus minus 3 is minus 7. So there's your two answers, and there you go.